So let's have a look at what we remember from last year. Hopefully all of this should be familiar to you. There shouldn't be anything new. The first thing we investigated in year 11 was the connection between degrees and radians, and we all learnt how to convert from degrees to radians, but the most important thing we had to understand at the beginning was that radian measure was based on the amount of turn around the circumference of a unit circle, which we know is a circle of radius 1 unit. And we had to remember that if we go in an anti-clockwise direction, we were dealing with positive angles, and if we went clockwise, we were looking at negative angles. So we remember using our basic measurement principles, if the radius is equal to 1 unit, the circumference of the unit circle is 2 pi. So 360 degrees, when we convert it into radians, is 2 pi radians. 180, it's halfway round, so it's pi. 90 is pi on 2, and 270 is 3 pi on 2 radians. So that should be really automatic to you. One thing you'll notice is I've used the little symbol, the little C, to indicate that we're working in radians. You would remember from last year that when we're working in radians, we don't have to worry about the symbol, but if we're in degrees, we absolutely must use the degree symbol. So that's going to tell you if the question is in degrees or radians. If there's this little degree symbol, you know you're absolutely working in degrees and your calculator should be in the appropriate mode. So to change from degrees to radians, we learnt the little rule that we want to have pi in the finished answer, so we're multiplying by pi on 180. And to go in the opposite direction, we want to cancel the pi, so pi needs to be on the bottom. And we did some basic conversions, 150 degrees into radians, multiplying that, we cancel that down to 5 pi on 6. And we can do that even if it's even if it's not a nice even number, just by using our calculator, 231.56 degrees. Plug that into your calculator, multiply it by pi on 180, and we get approximately 4 radians. Similarly, going back the other way, 180 over pi simplifies to 140 degrees. Notice I've used the symbol because I've given a degree measure. And if we're in radians, going to degrees, put that into your calculator, and you get 212 approximately. Okay, really easy stuff, quite boring and not really that useful to us. What is more interesting to us is the fact that with circular functions, we can do a lot of work without using our calculator. Those of you who are doing further maths would know that when you're dealing with sine, cos and tan, trigonometric ratios, or perhaps a sine rule or the cosine rule, everything's done on your calculator. You can't do anything by hand. Whereas in methods with our tech-free exam, we want to be able to do as much as possible without picking up a calculator. And we can use the beautiful symmetry of our unit circle to help us with that. So one of the most important things you need to start off by doing is recognising where your key angles are around the unit circle. And it looks like there's a lot of angles to remember, but because of the symmetry and the patterns, it's going to be really easy. So before the end of this week, you need to know all of these key angles all the way around the unit circle in radian measure. So the axial intercepts are really easy. We know that we start over here at 0, pi on 2, pi and 3 pi on 2. And in this case, we're going in the positive direction, which is anti-clockwise. We'll consider the negative later. So we need to fill in all of the missing angles at the end of these blue, red and green lines. So how are we going to go about doing that? Okay, so have a look at the page which has the circles which compare degrees to radians. And we're going to start with the middle diagram, which is measuring the 45-degree increments. Okay, when we have a look at this, we've divided our circle up into 8 sectors, 4 above the x-axis and 4 below. So we're starting at 0, and then if we want to work out what the radian measure is of those equivalent angles, we know the ones on the axial intercepts, the pi on 2, the pi, and the 3 pi on 2. But the missing ones, which related to the red lines in our previous diagram can easily be found by counting in pi on 4s. So starting here, going in an anti-clockwise direction, we start off at pi on 4. The next one is 2 pi on 4, which simplifies. Then we have 3 pi on 4. 4 pi on 4 simplifies to pi. 5 pi on 4. 6 pi on 4 simplifies again. And finally, 7 pi on 4. So that's filled in 4 of those 12 missing angles in our previous diagram. And the really easy way to remember the pi on 4s is to just look at the pattern, the coefficients of pi. It goes 1, 3, 5, 7. So it's a really easy sequence to remember. Let's have a look at the pi on 6s now. We've got this divided up into 12, 6 above, 6 below. Using the same technique, we can fill in the axial intercepts and then start counting in pi on 6s. So 1 pi on 6, 2 pi on 6 simplifies to pi on 3, 3 pi on 6, 4 pi on 6, which simplifies again, 5 pi on 6, 6 pi on 6, 7 pi on 6. Here's another one that's going to simplify to 4 pi on 3. Another one that will simplify again. And our final one with a denominator of 6 is 11 pi on 6. So when we look at the pi on 6 diagram, there are only 4 angles which end up with a denominator of 6. 1 pi on 6, 5, 7 and 11 pi on 6. So if we remember those, we can fill in were they the blue ones? I'll have to look back, I can't remember. Yep, the ends of the blue lines. Finally, if we look at the pi on 3s, well, we've already accounted for these in the previous one. 1 pi on 3, 2 pi on 3, 4 pi on 3, and 5 pi on 3. So the coefficients of the pi on 3s are 1, 2, 4, and 5. So now we should be able to complete that diagram that we had earlier, where we started off at 0, pi on 2, pi, and 3 pi on 2. So the pi on 6s are located really close to the x-axis, and the coefficients, if you can remember the number sequence, was 1, 5, 7, and 11. The pi on 4s were in the middle. It was 1, 3, 5 and 7. And the pi on 3s are the ones that are really close to the y-axis. That was 1, 2, 4 and 5. So your first job is to memorise or work out how you can find an angle, and it needs to be really automatic. And a really easy way to do it is to remember that the pi on 6s are either side of the x-axis and the pi on 3s are either side of the y-axis, and to remember those little number sequences.